morning, Year 9. So, what we've got here is just a video that is a couple of minutes just giving you some feedback on the work on ionic bonding that you have been undertaking this week. Now, we've evidently got a really good grasp of it from those of us who've been doing the online tutorials, been doing the exam questions, been having to go at the Educate quizzes that are associated with this topic that you've been set. So you've grasped in general the key differences between ionic and covalent bonding, in that covalent bonding is the sharing of electrons and ionic bonding is the transfer of electrons between atoms to get full outer shells. The bit where we struggled a little bit was just linking the group that an element is in on the periodic table to the fact that it tells you what charge an ion of an atom will have. So, for example, if you have got a sodium atom, when it loses electrons to get a full outer shell, it gets a +1 charge. And that is the same for anything in group 1. Any element in group 2 needs to lose 2 electrons to get a full outer shell transferred to another atom. So therefore, because every element in group 2 loses 2 electrons, that means every element in group 2 has a +2 charge as an ion. If you move up the groups, you'll see group 5. Group 5 needs to gain 3 electrons to get a full outer shell. So therefore, nitrogen, phosphorus, they have a -3 charge. Group 6, they need 2 electrons to get a full outer shell, so therefore they gain 2 electrons, which means they gain 2 more negative charges. So oxygen, sulfur, both have -2 charges. Anything group 7 has a -1 charge because they just have to gain 1 electron to get a full outer shell. In group 0, because they have 8 electrons in their outer shell, helium, neon, argon, krypton, xenon, radon, they do not form ions. So just key fact there, the group tells you, gives you that indication of what charge an ion will be from an element in that group. And then the other aspect is just thinking about how many ions need to bond together to form an ionic compound. So if you think about if you've got an element that forms an ion with a +2 charge. So for example, calcium. Now, calcium, because it's +2, it needs to bind with something that is a quantity of 2 negative charges. So that could either be a -2 ion or 2 -1 ions to make an ionic compound. So that's, for example, why calcium chloride is CaCl2. Because you've got a +2 binding with 2 -1 atoms, +2 and 2 -1 cancel each other out to make a neutral charge. That compound has got a full outer shell by all the atoms in it and therefore has a neutral charge. On the other hand, calcium just binds with 1 ion of oxygen because you've got a +2 charge and a -2 charge binding together to end up as an ionic compound. They've transferred electrons, they've got a full outer shell, and therefore they've got a neutral charge as well. So that's just a key feedback point from this last week's work.